In the last video, I demonstrated how to use list, walk, and find. The method name walk is short for walk the file tree, and in fact the files class already had a method called walk file tree that's been around since JDK 7. The walk file tree method walks the file tree depth first, as does the walk method. Depth first means that the code will recursively visit all the child elements before visiting any of a folder's siblings. The image on this slide tries to graphically show you what this means. If our current working directory has two subfolders, out and source, then the walk methods won't first examine all the first level paths, then examine the second level. Instead, it examines the first path, and if that's a folder, then it will walk into that folder, and so on. This probably feels rather natural to programmers, and seems a bit like a stack trace. The alternative is breadth first, which means any dependent nodes are walked after the sibling nodes. But again, walk and walk file tree are depth first. Because it is depth first, the files.walk file tree method provides a mechanism to accumulate information about all the children up to the parent. Java provides entry points in the walk to execute operations through a file visitor interface. This stubs out methods you can implement by overriding them at certain events in your walk. These events are before visiting a directory, after visiting a directory, when visiting a file, and at the point of a failure to visit a file. On this slide, I've included a simple class diagram for the file visitor interface and its simplest default implementation, simple file visitor. Here you can see the methods that correspond to those critical points in the walk. When you override these methods, you'll have the method arguments as data you can work with at that point in the walk. You can see from these method signatures that in most cases you'll have access to the current path, either a directory or a file. I didn't include the return type, which for all of these methods is the same, an enum value as shown on the file visit result enum. In addition, you have access to basic attributes on both the visit file and pre-visit directory methods. This is similar to the find method's predicate, which gave us access by one of its arguments. Okay, so with that high-level view, let's see what we can build with this method. I've created a new project for this video called FileWalker. Before I do anything in the main method, I'm going to add a static class as a member. I'll make it private, call it statsVisitor, extending simple file visitor, and since it's generic, I need to specify a type, which will be path. For now, I'll leave it like that. In the main method, I'll set up a path variable called starting path for my current working directory. This time I'll use the dot notation for the current directory. I'll set up a variable for an instance of my statsVisitor class. I can make the type the interface type. Because it's generic, I'll specify its type as path. I'll create a new instance of this class. Because I extended simple file visitor, I can use its default noargs constructor. Next, I'll call the walk file tree method on the files class, passing it my starting path and my instance of the statsVisitor class. As usual, I need to wrap that in a try-catch. I don't have to wrap this method in a try with resources, because this method will get executed at this point and resources will be closed as part of its execution. If I run this now, it's not going to look like it's doing anything. And that's because the simple file visitors methods just return continue the enum value. If I ran this on my root drive, it would take a pretty long time, but I'd still get no output. To make it useful, I have to override some of the methods on this class. Let's start simple and override the visit file method. I can do that with Ctrl-O, picking visit file from the dialog there. You can see this just returns a call to the superclasses method. I'm going to Control-click on visit file in that return statement. I'll copy those three statements and paste them where I had the return statement in my own method. You might remember that objects.require non-null simply throws a null pointer exception if the argument is null. This also returns the enum constant continue, as I mentioned previously. The value that I return from this method will determine how the walk is processed after this method. I can continue, or skip all my siblings, skip a subtree, or terminate altogether. The first thing I'll do is simply print the file name. Let's run the code and review the output. I'll get all the files in any of the subfolders or in the current directory listed out. Remember, this is depth first, so they're printed in that order. Right away, I hope you've noticed that visit file is really only visiting types that are files, although the file code styles doesn't have an extension, so it's hard to tell. How would I print the directory names? I can add code in another method, either pre-visit or post-visit of the directory. I'll do this in the pre-visit, so again I'll move to below the file visit method and pick pre-visit directory as the method to override. I will do the same thing I did before, going into the method of the superclass and copying its code, pasting it in this method. This code looks almost exactly like visit file. I'll add a println as well, this time getting file name on dir. Executing that code now. It's a little hard to see where everything belongs without indentation. One advantage of using a file visitor implementation is that you can keep track of some state during the walk. Let's do this with tracking the depth level. There are other ways to do this, but I'll show you this just so you can get an idea of how you might work with state during a walk of files and directories. I'll set up a private variable on my stats visitor class, an integer, and call that level. It's implicitly initialized to 0 because it's a class field. I'll increment this every time I visit a directory and decrement when I leave a directory. That means in the pre-visit directory method, I can simply increment this field. I need to override the post-visit directory next. And again, I'm going to use the superclass's code as my starting template. You might be starting to wonder why I'm even extending simple file visitor at all. If I decide to implement all 4 methods and I never call the parents methods using super, that's a pretty good question. Simple file visitor is a kind of shortcut option if you plan only to implement a couple of its methods. Otherwise, you could just have your class implement file visitor and not extend simple file visitor at all. Okay, so this code is a little different because one of the arguments is an exception, and here the code is throwing it, which may be a very valid thing to do. In my case, I don't want to stop executing if, for example, I don't have permissions on a folder, or really for whatever the case may be. I'm just going to comment that if statement out. Before I return from this method, I want to decrement level. Finally, in both places where I print out the path's file name, I'll include indentation based on this level. Let's run the code again and see what the output looks like. I'll see some indenting, which helps me see the tree structure. There are a couple of things I want to point out here. First, everything is indented, so this indicates that the pre-visit directory was invoked starting on the initial path or the current working directory in this case. You can see that path printed with the dot there. Second, our files are printed on the same level as their parent folder. We're keeping track of the level of the folder, not the files. The simple way to fix this is just to add 1 to level in that repeat method for our files, which I'll do. Running this code looks a bit better. Truthfully, you could have done this with walk in a lot less code. So why would you ever use this approach? Well, you probably wouldn't for this type of thing, but I wanted to give you a very simple example so you'd understand the mechanism. Let's actually talk about a better use case for this. Let's say you want to get the total number of bytes of a folder or the sum of its file sizes, and you want each parent's size to include all of its children's sizes. First, I'm going to clean up my code, removing the level field. I want to remove println statements as well. So first the one in visit file. In pre-visit directory, I'll remove the reference to level and remove the println statement. Finally, in post-visit directory, I'll remove the statement with level in it. Okay, to start with, I'll set up some new fields. The first field will just be the initial path, and I'll set that to null here. Next, I'll set up a map keyed by path with a value of type long, which represents the cumulative size of the folder. Instead of level, I can use the path's name count to figure out the level. This count is for the initial paths, and all paths will be relative to it. The reason I want this to be a linked hash map is because I want to maintain the insertion order, so my directories will get printed in order. I'll start with the code in pre-visit directory, since this is the entry point, for all accumulations. I want to set my initial path, if it's null, which it will be on the first visit to this method. I'll set initial path to dir only once here, the very first directory. I can figure out what the level is from the root or relative path this is by using getNameCount. I'll add an else statement next. I'll calculate the relative indentation level using the getNameCount on the current directory minus my initial count field. If the relative level is 1, I'll clear my map. You could maintain a map for the full walk, but if you're doing a large file tree, it's more efficient to keep track of one folder at a time. This also lets me print info to the user after each subfolder is calculated. I'll initialize the keyed entry to 0, the key being the path or the dir here. This ensures data will go in insertion order. Okay, so this code will only get exercised, meaning a map will get cleared and reinitialized for the first level of subfolders in my selected path. Next, I'll add a file size to the parent entry in the visitFile method. I'll use merge on my map. The key is the parent of this file because I'm accumulating sizes to the parent. This method will put a new entry in the map with the default value specified, 0 in this case, if the key doesn't exist. If the key does exist, then it will execute the function I enter here, adding the size of the current file to the parent's running total. The merge method takes a by function. The first argument is the existing value in the map, so I made that O for old. The second argument is the new value, which in this case is 0. So I want to take the old value and add my file size to it. The truth is I didn't really have to use a merge method here. I'll always have an entry for a path with a value of 0 because of the put in the pre-visit directory method. If you didn't care about the order that your directories were in, then you could remove that and put it in the pre-visit directory method, and this code would still work. I could have used compute if present, for example, but I did sort of want to refresh your memory on this for a later challenge. This code is tallying up file sizes on the parent folder, but these totals aren't propagated up to their parents yet. To do this, I'll include some code in the post-visit directory method. First, I'll check if the current directory is equal to the initial path. If that's the case, I'll just send back terminate and be done with the walk. Terminate is another value on that file, visit result enum. Continue would have worked just as well here, since when this current directory is equal to the initial path, the walk is over, but I wanted to demonstrate another option. Next, I'll set up a local variable, again for the relative level of the current path or directory, as I did earlier. If this relative level is 1, I'm back at a level 1 subfolder of my initial path. At this point, I'll print the data I've collected, so I'll do that with a for each on my map. Next, I'll get the level of each subfolder, subtracting 1 so I don't indent the first level. I'll print an indent based on the level, then the simple folder name in brackets, and then I'll print the cumulative size of the folder with commas, so I make that %(d). For the arguments, I'll repeat a tab using the level. I'll print the file name of the key, the path, and the value is the accumulated size of that folder or directory. If it's not the first level, I need to do a little more work, so I need an else statement. I will get the folder size for the current directory. Remember, this is post-processing, so this should have the correct size of this folder because all the children have been processed. I will do the same thing as I did with each file, merging the data for this directory's parent, adding the folder size here. Okay, that's it. Now the fun part, let's run it. If you're on Windows, you can use File Explorer to verify these values, opening the properties on each folder to check the size. Let's embellish this just a tiny bit more because maybe you really only want to look at that first level of summaries. I'll add another private field on my StatsVisitor class and call it printLevel, an integer. I'll generate a custom constructor, selecting printLevel as the field. This field will drive the output, and since the output is in the post-visit directory method, I'll go to that method. I'll wrap my output in an if statement. I'll check if the level is less than the print level and only print if that's true. To test this, I'll go back to the main method and pass one to the constructor of my StatsVisitor. Now, if I run this code, I'll get the directory sizes for the first level of subfolders only. If I change my path, this time I'm going to use ... which means use the parent path of the current directory. this will be the folder I have all of my IntelliJ projects in. Running this now. You might also get a lot of folders if you've been following along with this course and creating a project each time I do. Okay, so I hope this code took the mystery out of this method. I could have passed in an anonymous class to the walk file tree method, and you'll often see that done when you see examples of this method. If you're only overriding one or two methods of Simple File Visitor, then that's fine, but I think this way creating a static class is a little easier for others to read and understand what you're doing. In the next video, I want to give you a challenge, so I'll see you in that next video.